So let's talk about the search 2D metric too. So you have to write an efficient algorithm, and then there's a target in the metric, and then you have to search for it, right? So here's it. So this is a target. So you can actually use a brute force to traverse every single one of the column, one of the cell, right? And then to see if there are a cell in is equal to the target. If this is true, then you'll return true. If not, you'll return false. So again, you have to write an efficient solution. The brute force is not the efficient one. So for my solution, I start from the top left, and then I have a I equal to 0, I equal to 0, and j equal to m minus 1. And then n represent what? N represent the row, and then this is n, right? And this is n, and then my n represent a column, right? And this is it. So I will traverse from these cells all the way to what? I can either go down or I can either go left, right? So this is pretty much the idea. So what's the constraint? So if the I is less than n, this is okay, right? And also j is greater than or equal to 0. This is all inside the grid, right? So what happens if they are not inside the grid? So if there's a value not in the table, and then you have to get out of the grid to search for it, then you'll return false. So this is it, right? And let me just demo if target equal to 5. So if target equal to 5, right, I start from here, right? So I will say the num is actually equal to what? The metric ij, right? So 15 is a num. So target is 5. So is 5 equal to 15? No, they are not, right? So you don't return true. But 5 is what? 5 is less than 15, right? So if 5 is less than 15, then you probably need to what? You probably need to going down, right? So going left, right? So again, 11, going left, 7, right? Going left. Alright, now you have 4, right? So 5 is 5 less than 4? No, right? Then you're going down. So again, you'll find an efficient solution. You just go either left or bottom. So this situation, like you are not able to search for it. So you already get rid of the half of the grid. So this is much more efficient. So let's start coding. So I'm going to just define my n and m. So metric length m equal to metric at 0. Length I equal to 0, j equal to m minus 1. And then while I is what? I is less than n, and also j greater than or equal to 0, right? So in num equal to what? Metric at ij. If the target is actually equal to a num, I find it, right? I will return true. If not, if target is what? If target is greater than none, right? I plus plus, else j minus 9. Now you either going down, this is going down, this is going left, right? Everything else you cannot find it, you return false. So here is it, and submit. So let's talk about the time and space. This is space, constant, right? Even though you allocate the space inside the while loop, this is pretty much like constant. And then for the time, it does look like all of n times n, but the problem is you cut the metric into the half right away when you're going left or when you're going down. So this is actually all of n plus n. For the n is what? The row of the metric, and then the m is the column of the metric, right? So time. So here's my quick note. Time is n plus n, space is constant, and then n represent the length of the metric, m represent the then the flat matrix 0. Alright, so this is a solution, and I will see you next time.